Hello and thank you for watching my videos. In this video we're going to go over replacing an angle steam valve. So here's our angle steam valve. I've previously loosened it using 2 wrenches, one to back it up, one to pull it off. And if you look closely, the reason we're having a leak here is because this is cracked. You can see that crack right there. See it? It goes all the way around. So obviously needs to be replaced. So this is ready to come off because I've previously loosened it. We'll clean these threads up, tape and dope them, and spin the new one back on. However, on the radiator, it's a different story. I've had a lot of success with removing both of these, both the radiator valve and the spud, the radiator spud, with using heat. However, in some applications, and this is one of them, you may not want to use the torch because one, you're going to blacken the radiator, and 2, it's going to make a lot of smoke. So I try to remove them. They typically always break when you try to remove them cold. So if I was to heat this up, it would torch all this and make a ton of smoke, which is, you know, in some jobs it's fine, but not this one because somebody's living here. And so, as you can see, I previously tried to turn this spud and it broke, which is very common. So what we're going to do now is do a procedure called cut and collapse. So we're going to cut it here with a Sawzall, take this nut off, make another incision this way with the Sawzall, up to the threads on the radiator, but not into them. So we're not going to cut deep into the threads. We might scratch them a little bit, but the goal is to protect those threads. So we're just going to go in a little bit. And then after that is sliced out, sometimes we make another slice, and but typically on these brass ones, you just need one slice. And then after that is sliced, we're going to tap with a hammer and chisel until that piece will just fall right out, and then we can replace it. So here we're going to cut it off. Now we have something that we can work off of. You never want to cut these totally close. You want to leave some room to work with. So now I'm cutting the brass out up to the cast iron, but not the cast iron. So because I need 2 hands, it's hard for me to hold the camera and do this at the same time. But all we're going to do is just hammer this right down, right into here. And once we do that, the whole thing will loosen and come right out. So as you can see, just by tapping that, this just collapsed. And we can just take it out by hand now. The reason why this is a lot easier on this application is because we have 2 different metals. We have brass and cast iron. But you can do this on steel. You just have to, it's not as easy because the steel isn't as soft as the brass. So we're going to clean this out and run a tap through it, and then reassemble the new spud, the radiator tailpiece, and that would just go here with tape and dope, and then this would go here and just connect it up. And also we'd be mindful that the radiator needs to be pitched because this is steam, and you want, this is single pipe steam, I should say, this end to be high. There's a vent on the other side, so you want it to be pitched this way with this end low. So here, the new radiator tailpiece. The spud on it, internal spud is is piped and doped, so we use Teflon and pipe dope. Which pipe dope you use is your own personal preference. I've used Rectisail for like 20 years, and I just recently switched to Blue Monster. That's your own personal preference. So here's our spud wrench in action. As you can see, it's an internal spud wrench, and we're going to turn it, which tightens this right into the radiator. Again, I'm holding the camera with one hand, trying to work with the other, so we're just going to turn it. And you'd also want to hold back on the radiator as you're doing it. I have my elbow on it. Steam is, one pipe steam is typically run at a very low pressure. You do not need pressure in steam. If it's vented properly and your water's clean, you shouldn't have pressure in steam, because it works off of displacement. So when the steam system is off, all the pipes are full of air. When you create the steam pushes out the air through the radiator vent, which is right here on this side. And then when the steam reaches the radiator vent, it closes. Then when the steam condenses back to water, it opens and allows the air to go back in. And then it just repeats the process. So if your radiators are shooting water or spitting water, there's something wrong, and you shouldn't be wasting water, because you want to reclaim as much water as you can through condensation. So that's tight. You don't want to overdo these. You don't want to snap the brand new spud. And we're going to do the same with this. We're going to tape and dope this, spin the new valve right on. So we're taped and doped, and we're going to put the new radiator valve on. As close as you can get it by hand. Then we're going to use 2 wrenches to make it up. So this is only 1.25 inches, so 2/18 is fine. You don't, when you're dealing with brass, you really don't have to tighten it a lot, as much as you would if it were steel, because brass is much softer. This wrench I have here is a little big for the application, but it's what I have handy, so I'm going to have to put the wrench down so I can work 2 hands on the wrenches, so I have to put the camera down. So we made this angle steam valve up, and then we gently moved the radiator over to line up this ground joint union and tightened it up. So again, this being brass, you don't wail on it with a giant wrench, because you're going to strip it out and cause a leak. But it does have to be snug so that it doesn't leak. So one thing I wanted to mention is, it may have come to your mind, why did I change this radiator tailpiece out when it was just the valve? Why didn't I just change the valve and leave this piece and connect it? Well, the reason for that is because I've run across circumstances where the ground joint union on the new valve does not match up with the old valve. So, in other words, the new valve and the old valve don't line up to make a nice ground joint union like this does. So that's why I, without question, always replace the spud tailpiece on a radiator angle valve replacement. So you pretty much have to. So that's why. And so we're going to fire this up and test it out. Should be fine. So the steam valve is up and running. This is hot. Can't keep my hand on it. So everything went well. No leaks, which is the important part. And a couple of other points I wanted to make. When on this particular application, I use a fine Sawzall blade. This is a 614, 6 inches long, 14 teeth per inch. It's finer than other blades, and it allows you not to go too deep into the cast iron. So another point I wanted to make is, on a steam system, you would never modulate the radiator from this angle valve. This angle valve needs to be full port, which is basically all the way open. So you open it all the way and then back it off just a pinch so that you don't jam the stem open. So if for some reason this radiator was overheating and it was too hot in this room, the adjustment will be made on this vent. By turning the dial down, you would restrict the air going out, which the steam is pushing out. So the steam's pushing out the air. If you restrict that air, it's going to reduce the heat output of this particular radiator. So again, this valve should never be used to modulate the steam. It's basically, on a steam system, it would either be all the way open or all the way closed, two position. I've gone in jobs where they've had hammering problems, only to find out that through the person's ignorance, they partially closed this valve. And when you do that, you trap water, and then the water hits the live steam and can bang. So that's why you make the adjustment at the vent, not at the radiator valve. This is basically a shut-off valve if you had to disconnect the radiator or if you had an emergency. So, I hope you got something out of my video. Thank you for watching it.